From Photonics Media, this is the podcast that takes listeners inside the physical science of light, as we explore groundbreaking and industry-shaping progress in lasers, optics, imaging, metrology, and sensing. Each episode, our hosts welcome optics and photonics luminaries, rising stars, and market leaders for robust discussion about the trends shaping the field of photonics. From research and development to commercial innovation, we're on the air for unparalleled insight, offered on All Things Photonics. All Things Photonics is brought to you by PolyScience and Lumencor.
Today's episode is brought to you by PolyScience. For over 60 years, the PolyScience line of award-winning temperature control equipment has been helping the photonics industry reach its goals safely and efficiently. Our products are made in America and delivered globally. Please visit polyscience.com to learn how we can help you. Changing the world of chillers is more than a tagline. It's part of our history. Today's episode is also brought to you by Lumencor. Lumencor excels in the manufacture of technical lighting, scanners and imagers, and metrology. Visit us at lumencor.com to see how we can best support your new products and OEM production.
As we barrel into the month of June, we start with a check-in from the European Photonic Industry Consortium's technology meeting for photonics and XR, held in Helsinki in late May. The Microsoft Finland hosted event convened industry segment leaders and enthusiasts in AR, VR, and XR technologies. On site, EPIC's Jérémy Picot-Clémente, the consortium's technology expert for optics and AR/VR, spoke with preeminent changemakers from 3 companies innovating the XR space through photonic technologies. In a conversation between Stefan Steiner, CEO of LightTrans International, and Erhan Ercan, head of global business development at Morphotonics, the collaborators discussed the formation of a consortium that has proved instrumental in bringing developing technologies in early-stage trialing. Ercan sheds light on the importance of embracing what he calls a Friday afternoon project in this exclusive chat. And in part 2 of our opening segment, Jérémy Picot-Clémente speaks with Bharath Rajagopalan, Director of Strategic Marketing at STMicroelectronics. The pair run through the gamut of pertinent topics in the photonics for XR realm, including the AR Alliance and the present state of AR, VR, and XR solutions in a broader market context. Finally, in our feature interview, news editor Joel Williams speaks with Jason Sorger, Senior Field Service and Applications Engineer at DRS Daylight, about present and future technology endeavors.
So I'm Erhan Ercan with Morphotonics.
My name is Stefan Steiner from LightTrans, Germany.
So we came up with the idea of putting together a consortium, a loose consortium where we could show everything from design to measurements of an AR surface relief creating based waveguides. And it started out with LightTrans.
Right, you reached out at that time, and for us as a software developer and a designer, also in the field of augmented reality, it was very interesting for us because usually if people or other companies who want to do augmented reality designs, they have questions about design, but they never tell us any kind of parameters or results of application feedback. That's a pity for us as software developers and as opticians, optical engineers. And for us, that's, I think, was one of the opportunities we saw there in the collaboration when you reached out.
Yeah. So I think this was the case for every company in the consortium. We, as an equipment supplier of large area nano imprinting, shot as a glass supplier, as well as optofidelity on the measurements side of things, and NIL technology out of Denmark from mastering. All these companies basically do work for all the usual suspects, all the players in the AR world, but we cannot really publish any data based on the work we have done. So we decided, why not get together, do a complete cycle from design to manufacturing, again to metrology, so that we can actually publish our results using large area nano imprinting so that we can show the increased throughput and lower costs. And that's what we have done since 2022.
Yes, that's right. And I think the results were very good. So initially, it was not intended to show some final working demonstrator. We tried to keep it simple, quite simple design, and just show this complete value chain. But in the end, some guy just took the waveguide and put it in a demonstrator, right?
Yeah.
It was really impressive to see that that one working at a trade show.
Yeah.
And I think that's a really great achievement from this collaboration.
Especially in a world where people, companies spend billions of dollars with thousands of, engineers, and here we are. This was sort of a Friday afternoon project for all these companies. We're not saying that we did, the world's greatest waveguide design, but at least we showed the feasibility of manufacturing in high volume at lower costs a waveguide that is high quality.
Yeah, and just with some persons from companies from different fields of optics, experts in their field. In this loose collaboration, I would say, and now we are going to further continue, right? So
we published the results at SPIE XR, AR, VR, XR exhibition in San Francisco most of the time at the end of January, beginning of February. In 2022, 2023, 2024, there was a presentation Stefan presented, which was a full house, packed audience. And then in the years after that, we did the presentations, posters, and next year, 2025 XR, SPA XR, we're also going to be presenting. So the loose consortium continues.
Right. And we try to push the limits, like for the design. That means we further, let's say, make the design more sophisticated by switching to slanted grating instead of
lower residual thicknesses.
Right. That means better optical performance, but also better, let's say, manufacturing quality. And I think
and then
industry.
Yeah, and then at the end of the day, the idea is that there is other alternatives to manufacturing that are out there, which other than a wafer scale manufacturing methods that can result in high quality, waveguides at lower costs, and that was sort of the main consensus and the idea that we were trying to show.
Yeah, and furthermore, we're also trying to, let's say, further analyze the optical performance in future and trying to get some further deeper understanding how deviations in the fabrication or imprint can affect the optical performance. And I think due to this open collaboration and that we are allowed to share all the details and the information, this can be quite interesting.
Yeah.
Over the last 7 years or so, with ST particularly, I've been developing the strategy for AR for ST, and as a consequence of that, I realized that we have to work with many different partners in the ecosystem in order to enable, at that time, just a display device. And so through that journey with ST and with our partners and others in the industry, we realized at that time the idea came about that having a consortium of sorts, collaboration of sorts, is the way to move forward. So my role in the industry with ST is to really take ST's portfolio and leverage that for the AR market. And my role outside of ST, but also supporting ST with other companies as well, is to have a collaboration approach for the AR industry in general.
So it's a good transition because I would like also to mention AR Alliance. Can you tell us more about the AR Alliance?
Sure, absolutely will. So AR Alliance is something we formed officially in October of 2023. That was a rescoping of a previous alliance called the Laser Alliance. The Laser Alliance was dedicated to laser beam scanning displays for augmented reality, hence the LASAR. But then we very quickly realized that we achieved a mission, and the mission was rather narrow. And at that time, when Apple Vision Pro announced their product, and the industry started to wake up to saying, wow, we need to really address a lot of devices and a lot of the hardware in general, that's when we realized as an organization that we need to rescope and to think about AR in general, not just displays in particular. Hence, the AR Alliance was formed and officially launched in October of last year.
Okay. And how many members do you have now at AR Alliance?
Right now, I think we're about 2021 or so, and new members are joining, express interest all the time. So right now, we're about 2021, I believe, in that range.
And what was the initial need to identify why?
Sure, why? Yeah, it's a great question. I mean, again, what we realized is that the AR market, today, although there's a lot of hype out there, there's not a lot of substance yet in terms of actual products. And we asked the question, well, what is it keeping, the industry from being realized for so long we're talking about this stuff. And we quickly realized that several things are needed. One, an ecosystem that's robust, collaboration across the key partners, and an approach to developing and enabling development products through standardization is the ideas we had initially to sort of facilitate the market. Because if everyone does their own thing, their own approaches, and their own implementation, then it's very difficult for the industry to realize a consistent set of product experiences for the end user. So that was the thought process around the AR lines.
And if you go now a bit more in the AR market, you mentioned during the presentation you made during this technical meeting that so regarding the AR market, are we there yet? So can you give us your answer?
Sure. This is my opinion. Yeah. Are we there yet? I guess the question, what is there mean? Are we there from a technology point of view? I would say yes. By and large, yes, we are. Now, and with the caveat I'll talk about in a second. Are we there yet from a market point of view? I don't think so. So it's sort of the question has a duality to it. So in the former sense, I would say the technology is ready to have a product that's good enough as a first-hand product, both for simple AR glasses, call it that, as well as for more immersive. So I would say the technological foundations are there, the product bricks are there. So I think we're there to actually do something. Is a market there? The answer is no, clearly, right? I think we'll all agree that there's not a lot of product sales, particularly to the mass market for sure. It's not there yet. So are we there yet? Yes and no.
So what would be the key, to maybe to create a market? In your opinion, what would be the...
That's a great question. This is a crystal ball question, but I think that my crystal ball is really based on talking to a lot of people and a lot of experience with a lot of different companies. And so, I think what we need to understand is that what problem we're trying to solve. Right? Because right now, it's a solution in search of a problem. So people have all different solutions, all kinds of, we've got approaches, all kinds of displays, all kinds of specs. It's everywhere. And so the question we have to ask, what problem are we trying to solve? And fundamentally, I think if you look at some of the products that are out there, I think it's becoming clear to a lot of people, particularly to me, that having a pair of smart glasses that has simple informatic display that the average person can use is a great starting point. I will use as an example the Meta Ray-Ban glasses, right? That glass is only audio today, but it's solving a problem for people, right? Yeah. They can wear a device, listen to sound as well as the external world, but do it in a private kind of way. They have microphones and beamforming. They can pick up sound that's directional, for example. Now imagine, I can't speak for them, but imagine having a similar device with a simple display on it to tell you where are you going, what am I doing, just data when you need it. It's not a persistent use case of all day long, right? So I do believe that's where we need to start. I think it'll solve some problems. It'll be unique. It'll also allow for price points to be more attractive. So you don't put too much technology in there, and it'll get the people familiar, consumers familiar with some of the helpful use cases of it. So that's my opinion in terms of mass market. Of course, there's a whole other area of immersive, which is a separate topic. It's already there now. That'll continue to follow its own vector of growth. But for the mass market, but what's needed there also, the second part of your question is that we need to have standards. We need to have products that have certain requirements. So for example, like the conference today or many conferences you go to, people talk about field of view as an example. 30, 40, 50, 60, 70. I mean, we got to choose something, right? What are we going to standardize around, if you will, industry, or harmonize around? What do we think is good enough? What kind of interactivity do you want, right? How do you want to communicate and connect to this device? So all these critical technology bricks exist, but we need to agree on that standard of how we're going to do it so that everybody can now work towards developing products that's consistent, it's interoperable, and then the consumer can have a consistent experience as well, right?
So we need first to have standards.
Yes, I believe so, because it's a different device. So a very simple example is connectivity. So if I'm wearing a device, where's the data coming from? Right? Is it coming from the ether, the cloud? Is it coming from your phone? How is it? So obviously, the simplest thing is to use your phone or your watch, right? And so it can have a head-up experience and a hands-free experience. So connectivity, but there are no standards. So if you don't have a standard saying, hey, send data this way, here's your bandwidth, here's your latency, here's all your power that you're using and stuff, and working around that, then that's how that equation's off the table. Now people can focus on other areas as an example, right? Display, same thing. How bright do you want it to be? People say, I want brighter and brighter and brighter. Do we though? So we used to say, this is good enough for brightness, so let's not waste too much time. So we can standardize around that. So having these kind of standards allows people to then coalesce around requirements, so they're not constantly guessing all the time, right? Yeah. And so they can coalesce around these standards and then build products now with certainty without worrying about, oh, did I choose the right spec or not? Does it invest too much money? And am I losing money and choose the wrong area? That's the uncertainty. So you eliminate uncertainty by having standards for each person in the value chain, right? So everyone's more confident and assured that what they're working on will actually be realizable on the market. It is what the market wants. So they can now invest wisely and spend their resources wisely.
And this is also one of the role of AR Alliance, actually, to make these standards reality. And I was wondering also how much collaboration is important for making this real.
That's a great question. I say collaboration is the key. That is the mission of the organization, is to facilitate collaboration in a neutral environment, in a safe environment, for everybody to come together and work towards solving the problem. Collaboration is absolutely key and essential to have a thriving ecosystem. So yes, collaboration is important, and collaborating on standards, agreeing. Now, we're not always going to agree on everything, but having coalescing around an agreement and having trade-offs and coming to a conclusion is really important, and collaboration leads to that. So it's absolutely vital, collaboration. That is, in fact, I would say, one of the key operating philosophies of the organization's collaboration.
And maybe a last and more open question. I would like to mention AI, artificial intelligence. Sure. What is your opinion on the use of AI in this industry, and how it will be maybe important to approach the market?
AI is a great buzzword, right? Everywhere I go, you see AI. Everything is AI today. Of course, it's important. AI, as we know, it's going to be an important part of the human experience, human life. AI for AR in terms of the use of use cases and stuff, and I think it's just yet another thing is part of it, right? Maybe AI is part of how you communicate with the device. When you do a search or ask for something, maybe use an AI engine, AI bot to help you do that. So I see AI as just another tool or another application, another modality of how you use the glasses. But for the industry, I want to sort of pivot somewhat to another side, where AI is really incredibly important. I think one of the speakers mentioned it, I believe yesterday, is AI allows developers, researchers to really narrow down the field of possibilities in R&D. So for example, if you're looking for chemicals of a certain characteristic or compounds, to do literature search by itself and to go to evaluate every single compound, every single element, take forever. So I think one of the speakers talked about using AI to really narrow down the material set that's available in order to then have the R&D team focus on a few different materials with certain desired property. Whether the property is anti-reflectivity or the property happens to be some other optical characteristic, AI is a great tool in R&D to save a vast amount of time to enable R&D and engineering teams to come to a solution space that's more bounded. That's where AI is strong in any industry, especially in ours as well. But for the average user, I think it's just another application that sits there.
Okay, good. So thank you very much, Bharath, for your input.
Wonderful.
It was really relevant.
Thank you, Jérémy. It's a pleasure.
Thank you.
Publicly funded research serves as the bedrock of the modern technology landscape. GPS, cell phones, microchips, barcodes, airbags, and countless other innovations have made their way from government project to the public sector. DRS Daylight Solutions is one of the many companies navigating this space. Well known for quantum Cascade lasers, DRS produces an expanse of technology used in defense and government. Infrared countermeasures to defend against heat-seeking missiles, materials detection, and many other capabilities reside in the company's portfolio. DRS Daylight also develops solutions for medical and industrial sectors, and increasingly for quantum information science. Today, we speak with Jason Sorger, Senior Field Service and Applications Engineer at DRS Daylight. Sorger overviews DRS's current technology focuses and offers insight on the many sectors the company supports via its offerings and expertise. That conversation with news editor Joel Williams is next.
So right now, two of the biggest topics in photonics are quantum and PICs. For us on the news team, it'd be very easy to flood photonics.com and our magazines with just news on these topics. One of the larger funding forces behind these technologies, certainly quantum, is the military, who has a great deal of interest in developing those capabilities. Could you tell us a little bit about the impetus behind that? What sort of capabilities are being sought after, and how is DRS addressing that?
Yeah, definitely. So, quantum information science is really expanding and growing in its popularity, as you kind of mentioned. And there are a lot of kind of game-changing applications that could be affected by this new technology. Globally, we're estimating about $38.6 billion of government support for different types of quantum initiatives. And defense is definitely going to be one of those sectors that benefits from the development of quantum technologies, but not necessarily the only one. If we think about some examples of these technologies, like atomic clocks, is a very good technology for very precise timekeeping, which, if you think about it, could help synchronize missions across multiple time zones. Moving past that, being able to do very high detailed quantum sensing to help the men on the ground, or distribute quantum keys for secure and reliable communication. So all of these different types of applications, while not necessarily limited to just the defense sector, are certainly going to benefit the defense sector. And so kind of depending if it's public or private, all of these will work towards delivering a good solution for the continued expansion of these technologies. And to kind of frame it from our perspective, Daylight sees our role in the quantum market here as working with other key industry leaders to develop photonic engines. Right, this can be in the form of laser sources, or it can be in the form of a photonic integrated circuit, right, a PIC. In order to meet those reliabilities, or in order to meet the reliability standards that's really needed to execute well on these types of applications.
Excellent. Now, another hot topic right now is optical communications. A lot of companies are working in this space, and it's certainly, another thing that has a lot of interest from the military sector and also from NASA. And not just for the speed advantages over radio, but also for its increased security. What are some of the considerations that DRS is working with when designing this type of technology? And what are the applications that you're looking at?
I'm going to start by addressing some of the considerations. Well, and so where I'm going to really start here is talking about this semiconductor center of excellence that Daylight has acquired. So we have a facility out in Madison, Wisconsin, that is vertically integrated and is working on developing laser diode technology that has, long-term reliability and some very rigorous testing to make it such that it is qualified for applications in space. And why is this important? Well, I think if COVID-19 taught us as a kind of global society anything, is that supply chain robustness is a very critical factor in making sure that you can execute on building your different types of technologies. And so by having a U.S. located fabrication facility, we can offer kind of a very trusted source with us as a supplier to deliver these types of laser diode communication technologies that can really be used for satellite communication and other space-based communication applications.
Excellent. Something I was a little bit curious about was the crossover from a military project to a more commercial use. for some of these systems. As I understand it, you guys are looking to step a little bit further into the quantum market. Are there certain areas that you're looking at that would sort of benefit from that type of ruggedization?
Well, yeah, certainly. And ruggedization is a quality that extends beyond the needs of just defense applications. We're in communication. We hear from industry partners and from other market research sources that the next generation of quantum is going to need a laser solution that can, one, scale to meet demand, two, be miniaturized for manufacturability, and three, be reliable for long-term commercial use. And so all three of those characteristics are shared between the public sector of industry and the defense industry. And so we have a history of building quantum cascade lasers, right? QCL. And in that technology, we have taken a very sensitive device. Quantum cascade lasers are very sensitive devices. And we took that sensitive technology and we became experts in ruggedizing it to meet size, weight, and power constraints for, for example, infrared countermeasures. If anybody's not familiar, Daylight has, successfully deployed QCLs on U.S. rotary ring aircraft to offer defense against, missiles or other types of offensive things that might be coming to. So totally butchered that. Sorry. To defend against other types of missiles or something similar to that.
Certainly.
Yeah.
Excellent. One of the things that really piqued my interest when we spoke at DCS a few weeks ago was the Meerkat laser. Now, this is something that's designed for infrared spectroscopy, and as I understand it, infrared spectroscopy is sort of like a well-trodden path, but this laser seems to be pushing things a little bit further. Can you tell us a little bit about what led to its development? What problems were you trying to solve, and how does this laser address them?
Yeah, so you absolutely nailed it. Infrared spectroscopy is a very well-trodden path. There are a couple of different types of sources that will allow you to do infrared spectroscopy. FTIR is a well-established form of it's a well-established spectroscopy tool that can be used for these types of applications. However, the GloBAR, it's a very broadband light source that they offer. And so by introducing QCL, we're able to kind of address a couple of the areas that FTIR doesn't necessarily get addressed. The QCL itself is a relatively new technology, right? So this year is 30 years since that technology was first realized at Bell Labs. They did this back in 1994. And within that short time period, QCLs have really been adopted into this infrared spectroscopy application space, as well as other application spaces. One of the reasons that one of the problems that we're really addressing with the Meerkat laser in particular is the ability to offer rapid, high resolution, and broadly tunable coverage in the mid-infrared spectrum. The quality of light that you can get outside of from a QCL is very well suited for these types of applications. And so the technology here has been leveraged across a lot of different institutions globally, and it's been referenced in hundreds of peer-reviewed publications. Over the last few years, we ourselves have invested in improving our core laser technology and improving the quality of light that we can get from a quantum cascade laser, as well as the wavelength coverage that you can achieve with a quantum cascade laser. And so by moving these types of technologies forward, we're hoping to continue to address all of these questions that we keep getting asked.
Well, I was actually wondering if you could expand a little bit on, why the quantum cascade laser is so well suited for this application.
Yeah, so quite simply put, you can get a lot of power from the quantum cascade laser that you can't necessarily get with another source like a glow bar or a synchrotron. These are the two other kind of common sources for getting mid-infrared to far infrared light. By having additional laser power and a long coherence length, you can really maximize your, or I should say minimize your signal to noise ratio, maximize your signal, minimize your noise. And so that's one of the really key advantages. And the other is the rapid tunability. Being able to scan rapidly across, a set of wavelengths. If you're thinking about targeting one specific, molecule, atom, type of chemistry in particular, by scanning rapidly across that line, you can detect very fast. Think about, analysis of fuel and how fuel burns. You can do this very rapidly with a QCL, and to get good characterizations there. Yeah.
Very cool. And now, from a defense standpoint, what is the Meerkat used for? And what are some of the challenges in designing a laser system for those applications?
Well, yeah. So first of all, whenever you're thinking about defense, as we kind of mentioned earlier, it needs to be this sort of ruggedized solution. It needs to be able to work in all kinds of different environments. But specifically, when we're thinking about the applications, it comes back to spectroscopy, right? The Meerkat, as a laser system, is an excellent tool for spectroscopic applications. And so military research labs can use these to go out and understand types of environments, or if they're trying to probe and understand a really specific type of reaction, for example. In addition to that,
Jason, just one quick second. You wouldn't happen to have any like tabs open on your computer? Just our connection is just a little bit funky.
Oh, okay. So I have a lot open. I can start closing some Chrome tabs.
Okay, yeah, that'd be perfect. Yeah, that might help us out a little bit. We'll just pick it back up at that at that last question. And we can
got it.
We can just,
here we go,
cut this a little bit out here.
Thanks. Yeah, I'm getting a couple things closed out.
Okay, perfect. Yeah, it's already looking a lot better.
Okay, excellent.
Awesome.
All right. So how is that? I can keep closing down here. I got a couple more things I can close here.
Okay. Yeah, you should be good now. But
okay, fantastic. Okay, and we're back.
Okay, cool. Here, and I'll just ask the question again, and just to kind of prime you for it.
Yes. Perfect.
And now, from a defense standpoint, what's the Meerkat used for? What are the applications? When we think about spectroscopy, military maybe isn't the first thing that we think of. And what are some of the challenges in designing a laser system for these military applications?
Yeah, that's a excellent question. As we kind of hinted at earlier and mentioned earlier, the laser system needs to be ruggedized. It needs to deliver a consistent and reliable source of light, whether that be infrared or other wavelengths, such as for quantum applications. But in a military considering specifically military applications, it extends it outside of what you might think of, right? It's not necessarily field deployed laser systems, though they can be. It's also the military research labs that are doing the research kind of behind the scenes to really study and understand a wide variety of different types of chemical reactions, which could then lead to applications such as standoff detection. Right, standoff detection is a very challenging application and requires a very consistent, powerful source of laser light that can be accurately delivered And when we're thinking of standoff detection, now we are thinking of a field deployed source. And so that needs to be able to operate in a wide variety of temperature environments, sandy, dusty environments, for example, and be able to still have the laser beam pointing to the same location so that it's a very well-controlled device. And so by ruggedizing this technology, we can kind of ensure that those aren't necessarily variables that researchers or other people might need to worry about for their experiments.
Awesome. And could you just explain what is standoff detection?
So standoff detection is this, so to give an example of standoff detection, consider the monitoring of emissions from an oil well, right? Or the detection of pockets of carbon dioxide or methane in the environment. By sending a laser signal out and having a detector placed either on the other side or in a reflective mode next to the laser source, you can spectroscopically determine which chemicals are in the air and with what types of concentrations.
Okay, so this would be sort of, detecting something from a distance, to, kind of improve, safety conditions. So you don't have to go into, some sort of, hazardous chemical environment.
Yeah,
so to speak.
exactly.
Okay, great.
Exactly. Or yeah.
Awesome. And now, with the Meerkat, from our conversation at DCS, it seemed like something that really set it apart, as I understand it, is the beam shaping elements of it. And that seemed to be, one of the factors that really kind of, set it above, some of its competitors. Could you kind of expand on the importance of those elements, and whether sorry, I just I just kind of fumbled this question a little bit. Okay, here we'll
Take it from the top.
Yeah, we'll try that again. With the Meerkat, something that really kind of sets it apart from the competition is its beam shaping elements. Could you expand on their importance, and whether what DRS has done there with that laser might find application in other systems?
Yeah, so there's a fair amount of design producing the light that comes out of our QCLs, and it kind of all ties back to that same thread that we mentioned earlier about quality of light. And so by starting with a QCL, you inherently get to start with a pretty good gain medium, a pretty good source for producing a laser. We've done a fair amount of internal development in here to develop mesoscale optics to help form and shape that beam into something that is very close to an m² of 1, which is to say a very well-shaped laser beam. But in addition to kind of the optics development, we've also integrated a technology that we call 0 point. What that does is that that the 0 point technology really ensures that every time you turn the laser on, and specifically turn the Meerkat on, the output laser beam is going to go to the same spot every single time, which is very important. So the superb beam pointing is kind of a critical function for, as we just mentioned, standoff detection, or for something like nanoscale imaging. And so it's a kind of another way that beam pointing is eliminated as a variable from an experiment. You can kind of know that every time you turn your laser on, it will go to the same location and we'll be able to probe, accurately and consistently shot after shot.
Okay, yeah, that should be that should be about it. Hopefully the recording comes out well.
Yeah, I realized we went through that pretty quickly. Is that going to be enough, or do we want to either add questions or revisit questions to expand on answers?
That's a great question. Actually, here, let me just see if I can message message my coworker and just see how long his interview was.
Perfect.
Were there any in particular that you thought you could you might want to expand on?
Yeah, sorry for messing with the microphone there. I was
Oh,
trying to set
no
this
worries.
back up. Yeah, so I think I could expand a little bit more on our role in the quantum market.
Sure.
I want to drop external cavity diode laser because that's the type of technology we're making. And I want to kind of mention too that we've been able to. I'm trying to stay away from making this a completely commercial thing. I don't want it to be a commercial thing. I'm trying to keep this sort of
Yeah.
at an editorial level.
Sure. Yeah, we appreciate that.
Yeah. But one of the really important developments that we've made for quantum is the ruggedization of a laser source that can target all of these applications.
Sure.
And so, what would be a good question, right? So public or private, right? We talked sort of about our role in quantum.
Right.
We talked about the need for reliable, stable laser sources. And what I don't know if I did a good enough job of was saying that we are trying to address these sources. We're taking all of the knowledge that we've gained from other types of ruggedized laser sources and are applying it to the laser sources that are going to go into these quantum engines.
Sure. Actually, I did just get word from my coworker, and apparently his guest bailed. So, so if you've got the time, we could just kind of take that portion of it as kind of a practice run, and then we can just kind of go through again, and you can expand a little bit more on some of those points. And if you had if you did have any questions that you'd like to be asked, absolutely.
Cool. So what capabilities are being sought after and how is DRS addressing that?
Hold on just 1 second. Sorry.
No worries. I'm also thinking of how we can kind of ask this question so that I can shoehorn in all that other information.
Okay.
I think it's in the third section, so to speak, right? One thing I was also curious about was the crossover between military and commercial use for these systems.
Yep.
So in there, I think is the right place to try and expand. So it's great. We took our very sensitive technology of QCLs, we ruggedized it. What I want to now mention is the fact that we've been able to take our learnings from ruggedizing QCLs to a ruggedized external cavity diode laser that is a source for quantum applications. That's a good laser source for quantum applications.
Sure.
I'm not going to go through and mention product specs or anything like that.
Yeah, no worries.
Yeah, but I did kind of want to highlight the development of that technology because it is pretty cool. It's very new, very rugged. And you need ruggedization is important for laboratory users. It's important for people who are doing quantum communication, but it's also important for quantum computing. And so I want to kind of also mention that.
Yeah, that'd be perfect.
So what kind of, is there a question that you want to ask? How do we lead into this?
Oh, I think that's something that you could just kind of segue into naturally with that when you're talking about it.
Okay.
Do you see an opportunity to kind of segue into that, or because I could I could just kind of work it into the question as well.
Yeah, I'm thinking. Yeah, so I mean, if we could ask maybe about, I'm trying to think of the best way to word this. Ask about, what, well, so are there certain areas you're looking at that would benefit from that sort of ruggedization? Like asking that question over again and having the ability to just segue in. I think that section should have been 3 bullet points. 1, ruggedization is important for quantum. 2, we've ruggedized QCLs. 3, we have ruggedized external cavity lasers for quantum applications.
Perfect.
Again, trying to stay as not commercial as I can with that.
Sure.
And speak editorially. But to share, I mean, it's pretty cool. The fact that you can, load one of these lasers onto a table, smack it with, a dead blow hammer, smack the table with a dead blow hammer and have that laser not move is super important for quantum computers, right? If you're going to make an entire network rack so if you're going to make a rack to network together a bunch of quantum computers, you're going to need laser sources that are incredibly stable and not sensitive to heat, temperature, or mechanical shock. And so by having this ruggedized laser source, you can ensure long-term reliability and stability of your quantum computer or your quantum communication network or something like that.
Excellent.
And I realize I'm saying all of these words, and maybe if we can edit and cut them in. Or we can kind of take it from the top.
We'll take it from the top, but definitely mention that. And if there's something that you're excited about, don't feel like you have to hold that back. Like if something's like really interesting and you find it interesting, like absolutely 100% bring that, bring that energy to it.
Sweet.
We love that.
Okay, fantastic. Well then, so I think if we could maybe do another take on this third section. The one thing I was curious about was crossover between military and commercial. And if I could just take one more stab at giving that one an answer.
Sure. Okay. Yeah. So, just that one, or did you want to go through from the top? Because if you have time to go through it from the top, that would be great. But if you don't, that's no worries at all. I know we're all pretty busy, but
no, for sure. Yeah, right. I can take it from the top. That was a good practice round. Let's do it again.
Sure. Okay. Yeah, that might work out for the best anyway, because our connection right now seems to be pretty good with the just with the internet. Let's see. Okay, perfect. Yeah, because when I asked the first question, I hadn't read it through, so it came off a little awkward anyway. So,
gotcha.
I think this is for the best. Cool.
Fantastic.
All right. Yeah. So right now, two of the biggest topics in photonics right now are quantum and PICs. And on the news team, it'd be really easy to flood photonics.com, and our magazines with just news on these topics. One of the larger funding for, excuse me, goddamn. All right, from the top.
Water break. Hang on.
Sure.
All right.
All right. So right now, two of the biggest topics in photonics are quantum and PICs, and it'd be really easy for us to just, publish news on those topics, on our website and in our magazines. And one of the larger funding forces behind these technologies, and certainly quantum, is the military, who has, a great deal of interest in developing these capabilities. Could you tell us, a little bit about the impetus behind that? What sort of capabilities are being sought after, and how is DRS addressing those?
Excellent question. Thanks. From what we've seen, quantum information science is growing very rapidly in popularity and in scale. And as you mentioned, there are a lot of game-changing applications that could really be affected by this technology. Right now, globally, there's an estimated $38.6 billion of government support to help and motivate these different types of quantum initiatives. Defense absolutely is one of the sectors that will develop or that will benefit from the development of these types of quantum technologies. If we think of one example in particular is an atomic clock, right? Is by having very precise timekeeping abilities, the synchronization of missions, for example, across multiple time zones is now all of a sudden a capability. In addition to that, quantum sensing on the men and women out in the field, or distribution of quantum keys for very secure communications. So it's not limited to just the defense sector, though. The interest in quantum is certainly not limited to just the defense sector. Whether it's private or public, all of these quantum technologies are being driven, and a couple of the key driving parameters here are reliability and scalability. And so we here at Daylight Solutions see our role in the quantum world right now as working with key industry leaders and other types of partners to develop photonic engines, in particular PICs, photonic integrated circuits, in order to meet those reliability demands to really enable these applications to kind of get off the ground and become something that's a more commercialized and B, a lot more reliable in the long term.
Oh, excuse me, I was muted. Now you mentioned quantum sensing on men and women out in the field, and I was just kind of curious, what does that entail?
So that's a fairly new type of technology and actually a very new application in general. But by having quantum sensors out in the field, you're able to detect very, very small changes in either environment, personnel state, so on and so forth. And so by having that really reliable and robust form of detection, you can really track what exactly is going on out in the field and respond accordingly based on the measurements that you collect from that.
Actually, and I just want to skip ahead to a question, and then we'll just kind of come back to the other one I had prepared. But one thing I was just curious about was the crossover from military projects to more commercial uses. You've sort of touched upon ruggedization and building something that's very robust and can kind of handle some of the abuse that it's going to take from from a military application. And so as I understand it, you guys are trying to step a little bit further into the quantum market, as you've kind of mentioned. Are there certain areas that you guys are looking at that would benefit from that kind of ruggedization?
Well, yeah. So absolutely, ruggedization is definitely something that extends beyond the need of just defense applications. While it's important to have a laser source that can withstand operation in temperatures, in environments, we also hear from our industry partners and other forms of market research that the demands of the next generation of quantum will need to be scalable for this kind of reliable commercial use. I'm sorry. Could we take that from the top?
Sure. Yeah. No worries at all.
I'm gonna answer. Yeah, I'm deviating from our note here, just a little bit.
No worries.
Okay. So
that kind of works because you're kind of clipping in and out.
Okay. Good.
Oh boy, this is the shit show. That's all right.
We'll get it done one way or another.
Yeah. Okay. Let's see. Here, and I'll just move this up here. Okay. All right, perfect. One thing I was kind of curious about was the crossover from military project to kind of a more commercial use for some of these systems. As I understand it, you guys are trying to step a little bit further into the quantum market. And I was kind of wondering, the ruggedization that you've kind of touched upon in your last answer. Are there certain areas that you're looking at that would benefit from that type of ruggedization?
So yeah, absolutely. There are a number of different areas that would benefit from having a ruggedized laser source. So stepping out of kind of this defense sector that we've been talking about most recently, in the laboratory environment too, it's important to have a good stable laser source. Kind of speaking anecdotally, you want, if you're using a laser in a research laboratory at either a military research laboratory or even a university level research laboratory, you're going to have a lot of different people kind of working on this system. There are a lot of different environments that the system could be kind of deployed in. And so if you're thinking about mounting a laser on an optical table, you want to make sure that whichever grad students you're working with, if you're at a university, or whichever research scientists you're working with, if you're at a research institute or at a military research institution, for example, you're going to want to make sure that all users can put the laser down on the table, turn it on, and have it work. You want to make sure that dropping a heavy textbook, for example, onto the table isn't going to mess up your experiment. No reason that you should do that, but speaking anecdotally. And so having that ruggedized laser source, having that reliable laser source that isn't going to mode hop, isn't going to drift in frequency as a result of environmental perturbations, is really important out in all sectors and in all use cases of this. Thinking about, for example, building up a quantum computer rack, you'll be exposing the laser sources in that quantum computer rack to very extreme temperatures. And as a result, you need to make sure that your laser source isn't going to be affected by those extreme temperatures. It's also going to exhibit some mechanical shock and vibration, and you need to make sure that your laser source is insensitive to those mechanical shocks and vibrations. And so that's where ruggedization really comes into play, and is why it's so important to have in a quantum source. And so we have at, again, Daylight Solutions for a long time taken quantum cascade lasers, right? Different type of technology. But we've taken quantum cascade lasers, which are very sensitive devices, and we became experts in ruggedizing them to meet size, weight, and power constraints for infrared countermeasures, for example. For those who aren't immediately familiar with that application, QCLs are deployed on U.S. rotary wing aircrafts to defend against missiles. And so by taking the knowledge that we gathered working on our QCL systems, we were able to take those same learnings and apply them to developing a ruggedized external cavity diode laser that is geared towards meeting the rigors of the applications of quantum, whether that be computing, sensing, so on and so forth.
Excellent. And now, what would that kind of look like in a one of those more commercial applications? How would those really kind of benefit from ruggedization, do you think?
Yeah, so the real benefit is that the laser is no longer part of the experiment. The laser is a reliable and reliable source that you can install, turn on, align, and then forget about. Not forget about, but use in a way that that shot after shot, your laser source is going to produce the same quality of light.
Excellent. Now, sort of sticking with the theme, of the first question of hot topics in photonics right now. Another one is optical communications. And there's a lot of companies that are kind of working in this space, and it's certainly something that has a lot of interest from the military sector and from NASA. And that's not just for its speed advantages over radio, but also for its increased security. What are some of the considerations that DRS is working with when designing this type of technology? And what are some of the applications that you guys are looking at?
Yeah, this is absolutely a hot topic. So some of the considerations to address your first point are having a space qualified laser product. So Daylight Solutions has a semiconductor center of excellence located in Madison, Wisconsin. And through there, we have kind of truly vertically integrated the capability to produce laser diode sources that have been packaged in a ruggedized package that is space qualified, that can be deployed onto something like a satellite, for example. And so when we're designing these types of technologies, we're taking all of those ruggedization lessons that we've learned, and we're applying it to this miniaturized package that can be delivering a very consistent source of light. And so it's one of the things that we kind of learned kind of as a result of COVID a few years ago is that it's very important to have a robust supply chain. And so we took that lesson of having a robust supply chain and we used it to really motivate our own technology to become a reliable source of these types of optical communication lasers.
Right.
Yeah.
Now, actually, kind of sticking with the theme of ruggedization, when you're designing a laser for like a satellite, how much more rugged does it have to be? You see, every now and again you'll see a photo of like like this little tiny piece of debris that hit like the space station or whatever, and it leaves like this big kind of crater. Is is that kind of a consideration that you guys are thinking about when you're designing these systems?
So the bigger considerations that we're thinking about when designing these systems are the ability to, again, this leads back to mechanical shock, and then space, as that final frontier is a very extreme environment. Inside of the satellite's a different story, but we still need to be able to have it be in something, we need to integrate the laser into a package that can withstand A, the vacuum of space, and B, the very cold temperatures of space, and still be able to produce that reliable source of laser light. Sure. And so these packages are very well sealed, to allow it to operate in that vacuum of space, but also to really deliver that consistent and reliable light source. That one kind of.
So one of the things that I'm interested in discussing was something that we talked about a little bit a few weeks ago when we met at DCS, which is the Meerkat laser. Infrared spectroscopy, as I understand it, is a pretty well-trodden path. But this laser seems to kind of push things a little bit further. Can you tell us a little bit about what led to its development, and what problems were you guys trying to solve, and how does this laser address them?
Yeah, so you are absolutely right. Infrared spectroscopy is a fairly well-trodden path. However, one of the things that we were hoping to address here is improving the quality of data that you can get, and in your spectroscopy experiments. And the way that we're trying to help improve the quality of data is by improving the quality of light that's used as the excitation source. Quantum cascade lasers, QCLs, are a fairly new technology, relatively new technology. This year actually is the 30-year anniversary since Bell Labs was able to make a QCL back in 1994. And so within that very short time period, we've seen QCLs be adopted into a variety of different applications. One of the heavier ones, or one of the more common ones, is in spectroscopy. So the Meerkat laser was one solution that we've come up with that offers rapid, high resolution, and broadly tunable coverage in the mid-infrared region, sometimes also known as the fingerprint region, because there are a variety of different molecules that have molecular fingerprints in that wavelength band. And so the reason that QCL is well suited for this is because it provides a very high quality of light from the QCL engine that's inside of the Meerkat. And so we've also seen the Meerkat be adopted into a lot of applications where sensitivity is very critical. And so this technology has been leveraged across a multitude of institutions around the globe, and has been referenced in hundreds of peer-reviewed publications. Over the past few years, we at Daylight have been very invested in improving the core laser technology, right? Really improving that core QCL engine to offer greater wavelength coverage with higher power. And what that translates to is a very high quality of light that will provide beneficial signal to noise ratios when you're taking these types of data measurements, right? High signal, low noise is the goal. And so by continuing to evolve QCL technology, right, we're taking something that only 30 years ago was first developed into something that is now very widely used around the world.
Excellent.
Yeah.
And now, from a defense standpoint, what kind of applications is it used for? Defense might not really be the first application that people think of, when they think about spectroscopy, or maybe it is. But what are some of the challenges in designing a laser for those applications? And I guess, what are those applications?
Yeah, no, excellent question. And it's a point. It's interesting to consider, right? When you think typically of some military or some defense sector laser application, you are thinking, let's get the laser outside, let's subject it to rugged extreme environments. And so we come back to that sense of building this reliable source of laser light. But it goes beyond just some fielded system. Military research facilities are using Meerkats and other types of spectroscopic tools to characterize many different chemicals of interest. In particular, one of the more challenging applications that you can have in this sort of military sector is the standoff detection. And so standoff detection is a very important application because it allows the laser to probe the environment, to give the researchers and to give other people understanding of what's out there. For example, if we're talking about monitoring emissions from an oil well, you can use this laser source to go down to the whatever chemical might be emitted, methane, CO2, kind of, et cetera. And you can probe the quantity and the exact particles that are being emitted there using a standoff detection scheme. And so having a very powerful laser source for this, A, is required, and B, that laser source needs to be stable over time. And so that's really where we have that advantage, right, from the high quality of light that is offered from a QCL.
Excellent. And I was wondering if if the Meerkat is this isn't just something that's for defense, or is that kind of primarily where where it's focused?
Yeah, no. So the Meerkat is used in research facilities, right? Military research facilities for characterization of different types of chemicals, but it's also used at research institutions like universities worldwide for very similar types of applications. One of the benefits of the rapid scannability or the rapid tuning that you can get out of a Meerkat is the ability to do combustion diagnostics and analyze really extreme, for example, burning of fuel and the outgas and all of the byproducts that are created as a result. And so it's beyond just military research institutions. It's really any type of research institution that is doing different or doing really any kind of spectroscopy type work.
Excellent. And now, as I understand it, from the conversations that we had at DCS, one of the things that really kind of sets the system apart is these beam shaping elements. Could you kind of expand on those, on their importance, and whether that type of technology, might find its way into other systems, or future systems, or maybe even existing systems?
Yeah, definitely. It's again another interesting point that you bring up. So we here at Daylight, by getting to start with the quantum cascade laser as the gain medium for our laser, we're already setting ourselves up for success because this will produce a very high quality of light. We've done a fair amount of internal development work, developing mesoscale optics that can shape the beam coming out of the quantum cascade laser. And by doing so, we've been able to form a fairly nice looking laser beam or laser spot with low divergence and the very favorable m² value, like m² very close to 1. But beyond that, beyond having, and so that kind of addresses the first problem, is you need to produce a quality laser beam. And so we do that with our beam shaping optics. More importantly, though, is making sure that that laser beam is delivered where it needs to go. And so for that, we went through and developed a technology we called 0 point, which allows multiple different QCL laser sources to all point to the same spot to within less than a microradian. And so that superb beam pointing is very important for applications like I just mentioned, standoff detection, making sure that that laser light is being delivered to the same spot every time. But then also could be very useful in nanoscale imaging systems, for example, in making sure that your laser is pointing to the same exact spot so you can get and develop good 2D, 3D profiles of very thin materials, for example.
With that, we conclude another episode of All Things Photonics. Thank you to our sponsors, to the technical staff behind the scenes, and to continued support from the Photonics Media editorial team. As always, questions, comments, thoughts, and ideas are welcome. Let us know how we're doing via email at allthings@photonics.com. All Things Photonics is available on all major platforms and on our website, photonics.com.